So we've spent days 1 and 2 talking about solving by graphing. And then we talked about when graphing, we can have intersecting, one point where they touch, parallel, no touching, and coinciding where they touch all the time or they're the same line. So graphing is not the only method to solving systems of equations. So the method we're going to talk about today is called substitution. And so the steps are written down here. So again, if I was making a pink sheet, I think this is something that would go right on my pink sheet. Okay? Being able to write down the steps to solve by substitution. Okay? So eventually we are going to talk about 3 different methods. Graphing we've talked about, substitution is today. All right. So I'll do my best to color code these. Isolate one variable. I have it right here. That means get X or Y alone. Oftentimes it doesn't matter. Okay, so I need to get one of them alone. I have that. Okay, so there's step 1. Step 2, substitute it into the other equation. So I'm going to plug it in right here. I know what Y equals. Y equals this. And I'm going to plug it in right here. Okay, so I'm going to do negative 2x minus 3. Y, the variable we got alone, is the same or equals 6x minus 11. And then I'm going to keep copying. Okay, so it's the same problem, but I hope you notice now you should have either all x's or all y's. Okay, combine like terms and solve for the variable. All right, so in this case I'm solving for x because I have all x's. Okay, so step 3 I'm going to show here in red. I'm going to distribute this, so I have negative 2x. Negative 3 times positive 6 is negative 18x. Plus 33 equals negative 7. These two are on the same side as my railroad tracks, so I need to combine them. Okay, I'm trying to get x alone, so I need to subtract 33. And then divide by negative 20, and I get x equals 2. Now, if you've been paying any attention for the last 2 days, you remember if we have an answer, it's a point. It's an x and a y. So even though we're not graphing it, we need to know that point. Okay, so if you look, step number 4 says plug it back into one of the equations. Okay, I'm going to plug it in right here. So step 4, I'm going to put right here. I'm going to copy down the equation I decide I want to use. It doesn't matter which one. Both will give you the same answer. And then I'm going to plug in 2 for x. So I get 12 minus 11, and y equals 1. That's my answer. Okay, so my answer, my overall answer is a point. Point where these two lines cross, 2, 1. Okay, step 5 is to check. Okay, if I plug in 2, do I get 1? 6 times 2 is 12 minus 11, I get 1. And how about the other one? If I plug in 2 and 1 here, I get negative 2 times 2 minus 3 times 1. Does that equal negative 7? I get negative 4 minus 3 equals negative 7. Check. Negative 7 equals negative 7, and it works. If you get something other than what your answer is, you need to go back and check. All right, we are going to start over with a new example. All right, so number 1, isolate a variable. It doesn't matter which one you choose, but I'm going to choose this one because I don't have any leading coefficients. And it doesn't matter which one you choose. Today, I'm going to choose to solve for x. Okay, so this was step 1. I solved for x. Okay, step 2 is going to be to plug it in. So now I'm going to take this x and plug it in right here. And instead of x, I'm going to use what it equals, which is 5 plus y. So step 2, I'm going to take 3, and instead of x, I'm going to write 5 plus y less than 2y equals 12. Okay, remember this has to be all one variable. Okay, and as you can see, it's all x's for me right now. Okay, step 3 that I'm doing in red, I'm working on solving. So I'm distributing. Oops, 3 times 5 is not 35, misvote. It is 15 plus 3y minus 2y equals 12. Okay, these are on the same side of my railroad tracks. So I can combine them. When I do, I'm left with 1y. Subtract 15 because I want letters on one side and numbers on the other, and I get an answer. Okay, again, this is not enough. Okay, we need to plug it back in. You should plug it back into one of the originals. I'm going to plug it in here because that sounds good to me. So x minus y equals 5. X minus, and I'm going to put my number here. Okay, this is like distributing a -1. So this is like x plus 3 equals 5 now. I'm going to subtract 3 from both sides. And I get x equals 2. Okay, your last step then is to check your solution. So if I have 2 comma -3, if I plug it in here, I get 2 minus -3 equals 5. Check. And if I plug it into the other one, 3 times 2 minus 2 times -3 equals 12. I get 6 plus 6 equals 12, and check. Okay, my solution is the point 2, -3. Okay, you start this one on your own. It doesn't have the steps. You should pause and see if you can work through this on your own. Then hit play and watch me work it. I'm going to start with this one, and I think I'm going to solve for y because there's no coefficient. Okay, so step 1 was solve. I'm going to plug that back in right here. Step 2 was to substitute. And you can see as I do this, I now only have one variable, and it's all y's. So I get -36 plus 12y plus 2y equals -8. These are on the same side of my railroad tracks. Okay, so I can add them together. I have 14y here. Okay, I'm going to add 36 to both sides. Okay, I think I get -28 here, positive 28. And divide both sides by 14. And I get y equals 2. Okay, I need to plug it back into one of the equations. I'm going to plug it back into the top equation. Again, it doesn't matter. So I'm going to plug in 2 for y. 8 equals 12, subtract 8, and I get y equals 4. You're going to write your answer as an ordered pair and make sure that you plug it in to check that it makes sense for both of them. So -12 plus 4 equals -8, I agree, and if I plug it into the top one, I also get it to work out. So you should always check, even though I glossed over that step a little. If you got lost at any point, make sure that you pause and go back and rewind. All right. So this one looks like it's going to be a little different because I see that there's a note here that there are 3 possibilities. So let's just do our best to walk through this and see what we get. I do not have to solve. So I can plug that right in. And I think I know what these 3 possibilities are. Hopefully you're remembering from graphing that I can intersect at a point, right? So I get x comma y. I can be parallel and have no solution. Parallel, no solution. Or I can be coinciding, remember the same line, and have all solutions. Okay? So, keeping that in mind, because I have that hint there, I'm going to go 6x minus 3. For y, I have 2x plus 4 equals negative 12. Okay, I've got all x's now. I'm going to distribute. So I have 6x minus 6x minus 12 equals 12. These are on the same side of my railroad tracks. 6x minus 6x is 0 x's. And in the end, I have this. Okay, so I'm going to circle back to my 3 solutions. And we've talked about how this is true, right? So when I think about this, do they intersect at a point? Nope. And I can tell because I don't get an x equals or a y equals. Okay, now what do I have? Parallel no solution or coinciding all solutions. And we've talked about when it's true, it's all solutions. And that happens here too. Okay, these two lines are coinciding. And we know that because we got a true statement at the end and we don't have a point where they cross. Okay, if the answer was 0, parallel would be something like this. 0 equals 2. Okay, we know that that doesn't work. There is no solution. And then our last slide today is a word problem. So the 10th grade class at Burnsville has teachers and students. So I'm already thinking to myself that teachers and students are what I'm talking about. So if I add together the teachers and the students, I have 642 of them. Okay, students is 30 more than 17 times the number of teachers. So I know that if I took the number of teachers and multiplied by 17 and then added 30, I would get the number of students in the building. Okay? Well, not students in the building, but 10th graders, right? So define the variables. I listed that up here. Okay? X and Y. Write your system of equations. That I've done. Solve the system. So we can go back to those original steps. Isolate the variable. I've got that right here. I'm going to plug it in here. So x plus, and instead of y, I'm going to write 17x plus 30 equals 642. Combine like terms. Okay, these are on the same side. Okay, subtract 30 from both sides. So I have 18x equals, what, 612. And then I'm going to divide by 18. Okay, I'm going to get out my calculator for that. That's one that I just cannot do in my head today. 612 divided by 18. Oops. 18. And I got x equals 34. Okay, remember that is not enough. We need to plug it back in. So I have 34 teachers. I'm going to plug it back into the one that looks easier to me. So 34 plus y equals 642. Y equals 642 minus 34. And I get 608 students. Okay? So my answer is 34 teachers and 608 students. All right, your homework is below. Let me know if you have questions.